Yes, Nick, Kapp from Skyline College, and Ying-Tsu, who's the associate director of at BayBack, to give us their presentation on how to teach supply chain management. Thank you so much.
Thanks, Purnima. Nick, I think I'll start, right? We didn't talk about that part.
Yeah.
So I'm going to start. I'm going to share my screen. And this is a very interesting piece that you brought up here, Linnea, because some of the recap that you mentioned was about supply chain as well, about supply chain of antibodies, and the fact that we need to collaborate more. And Angela's idea about ag biotech, yay. I'm all in for that. My colleague, I think Angela Mizra is here too, and we just recently received an ag biotech grant. So we are very excited about getting that started. And today I want to talk to you about teaching supply chain in the classroom. And my excellent man in cahoots, Nick Kapp, will also be following me in this talk as well and giving a case study on that. So I'm going to do the presentation mode, which, okay, good. You're all still here. I can still see some of you. So I'm going to go forward. We're going to talk about supply chain, multiple definitions. So right now, I want you guys to think about supply chain, where you have heard it, what you think it is. And then I'm going to give you a definition of what we say our supply chain is and why teach supply chain. So something else that Linnea said that was very interesting was that, there's the pharma side, the nimble side, and the biomade side. Well, supply chain is also another area that we can bring in more diversity to our students in terms of learning about biotechnology. Leslie said something about business. Well, supply chain has a lot of business in it as well. So this is a whole nother area that we can excite more students into biotechnology, biosciences, because the jobs are out there. Nick will also say something about a supply chain game. We get to play a little bit, and then give you the examples of biomanufacturing at Skyline College. Okay, there we are. You see us? Okay, so I asked you to think about supply chain, and maybe the Suez Canal popped up in your head. And when that came about, it was actually sort of funny, because how can this big ship get stuck? And something that's been going on for many, many years, and we've never had this happen. And yet these cargo ships are getting bigger and bigger. And there were some people panicking about maybe toilet paper, but a lot of Intel chips and electronics and gas. So there was this idea of another thing to worry about. We also had this idea that we were low on toilet paper for some reason over a year ago. So everybody rushed to get toilet paper. And then the toilet paper industry told us, we are not low on toilet paper. On the right here, you see the toilet paper consumption. And you can see Americans use a lot of toilet paper per capita, which I find really funny. I think it's partly because none of us, or most of us, don't have a bidet. So maybe these are ideas that you have about supply chain, and you've heard about it now. Here's another, oops, I can never figure this out about moving forward on this.
Enter.
Enter, okay, thank you. No, I gotta move your gallery. Okay, there we go. Did I do that right? Yes. Okay, so then what is supply chain? I went on Google and I looked it up, and I had all these images and go, oh my gosh, no wonder everybody has a different idea of what supply chain is. So here's I'm missing a slide. Here we go. So supply chain in sort of a 50,000 level, a foot level, is the raw materials that get sent to the supplier, to the manufacturer, distribution, customer, finally going to the consumer. It's a network, it's a chain. It's going from one thing to another. So that's a very high level of thinking about this. There's another level that maybe we're more so aware of during this pandemic, is that people talked about having a supply chain for vaccines, and we have to think about what is needed for that supply chain. maybe people don't think about needing glass vials, but we need that to store our vaccines, and then it needs to get manufactured. We need to think about the raw materials, the equipment, etc. Then it gets to, then we have to store it. So there were all these pictures of all these freezers to store the vaccines. And then finally it gets shipped out. There's no plane here, but there should be logistics to get sent to the customer, or the hospitals, the CVSs, etc. And then finally it gets to us. So imagine if any of this chain is blocked, what would happen, right? The consumers aren't going to get it. In the United States, we're very, very lucky in that a large part of our population have the vaccine. There's countries that have not had the vaccine. We're worried about Japan and the Olympics, that most people in Japan have not had the vaccine yet. Okay, here's another level. So just zooming in. This lovely image, I hope that most of you are familiar with it because it comes out of Todd Smith and Sandra Porter's website, Biotech Careers. And this is even more granular. This is the making of the Pfizer and Moderna vaccines. And you can see it starts at DNA manufacturing that, today we'll hopefully hear a little bit about from Twist, going all the way to distribution, and part of that is like RNA manufacturing, lipid nanoparticles. Like, did you even think about lipid nanoparticles when you thought about the vaccine? There's fill and finish. Then there's how to distribute that. So this is a very granular at the ground level of how the supply chain can be working. So there's all these levels. And I just want to bring you back now to the level that we are talking about with our supply chain, especially in the Bay Area, which we call Bioscope. So in our supply chain, we get orders from high schools. And I say we as in BayBack. And then we work with multiple community colleges in the area to make supplies. Here's a picture of Skyline College, their awesome facility, everyone doing the right thing with their PPEs. And then the supplies are then delivered to BayBack. There I am, driving around the Bay Area. And then it gets to the high schools. And the nice thing about this supply chain is that we don't have to worry about FDA. We don't have to worry about all those really harsh, difficult type of regulatory, because it's going to the high school. It just needs to be safe, basically. And most of what we do are safe. Our lessons are safe. And it then allows the high school students to also experience biotechnology. Mindy just chatted that they have a hard time with enrollment. We also have a hard time with enrollment here in the Bay Area. And what we want to do is that we need to start earlier. How do we start earlier? We go to the high schools. I think eventually BayBack will go into the middle schools to get students excited about biotech and what's out there in the community colleges. If we're seeing 30 to 60% of our students coming back with 4-year degrees, there's something wrong there. We need to start them off at the community college with those skills. So, and then there's the end with the results and doing the experiment. So let's see, next slide. Okay, so our supply chain is also about making useful products. If you're a young parent, Thomas the Tank Engine is all about being useful. So our students are technicians that are making useful products that are going somewhere. The auger plates, the plasmids, the calcium chloride, the lysis buffers, the meter bottles. You guys talked about making proteins, no more GFP that you dump down the drain. You're making antibodies. So I have a message here for Maggie. Is she on? Message to Maggie, if you're out there. We need some antibodies for Eliza. So if you're making antibodies, we'll take them. And one of the projects that just got funded is the making TAC polymerase. How about making some TAC polymerase that we can share amongst all our colleagues with InnovATEBIO? So think about how we can do that and help each other, help the community, and collaborate with the community. So another piece of the supply chain is learning the business side. And we recently have been having these large meetings with industry and with faculty. And what we have heard from industry is that students need to learn the business side of biotechnology. And with supply chain, it's called supply chain management, functional supply chain, integrated supply chain. And those skills are also in project management. So learning how to sort of think ahead and see what's needed. Down here on the chart are our way of managing the plates that are needed, for example, for going to high schools. So you can see Laney College making so many plates that needs to be delivered by a certain date. And here's an example that I thought was really good about learning the spectrum of supply chain management. So as an example, we tell our producers, we need 5,000 plates of LB auger and LB era and amp plates in 2 months. So then they have to think about the demand planning. How do you make that in 5,000 plates in 2 months without a plate pourer? Luckily, we do have Skyline with a plate pourer now. So you have to think about how many plates you got to have, how much media you got to have, how many do you have at the moment, inventory management, where are you going to store this stuff? Where am I going to put the plates before they're sent out? Who's going to pick them up? How do I schedule that to get them there on time? And how was that product? Was there any contamination? So you're integrating quality in all of these pieces as well. In a manufacturing sense, this is circled because this is what we focus on in our classroom, you know. And so how many times do we meet as a class, as a club? How many students are going to be available to help make this product? Despite the fact that we focus on manufacturing, there are a lot of other parts in it, and putting the manufacturing piece in context of the supply chain management is so valuable for students to understand the business side of biotechnology. So here are some job titles for supply chain. You may be wondering, what do you look for? So I have this lovely picture of Alan Yee, who was a student at Laney College. He came out of CSU East Bay, and he was this excellent student coordinator that we had for Laney. And he's now a purchasing manager at Perfect Day Foods. But what are other job titles that we have here? We have inventory specialist, logistics associate, fulfillment associate, buyer, kitting. Kitting is actually a job title. We do a lot of kitting with Skyline and with Laney College. And down here is I just put the description about the role. So duties will include building, producing, kitting, components, assembling, additional activities, materials movement, outbound. So all that is part of supply chain. And students who aren't necessarily good at the lab, there's a lot of other areas that they can be good at too. So now I want to go to my colleague here, my friend in cahoots, Nick Kapp, and maybe you can share your screen, Nick. Thank you so much.
Hey, good morning, everyone. I'm going to share my screen in a second. I believe that is it there. God, we've been doing it for so long. You'd think I'd be really good at this by now, but we're not. Ying-Tsu, thank you for that talk. And I may repeat a little bit about this, but being an educator, I say that you need to hear things a couple of times. So so bear with me if you do see it. Do you guys remember these days that you had basically a classroom full of students, everyone not wearing a mask, everyone right next to one another? On your right should be a lab where basically we had about 32 students in there, kind of right next to one another. What all these things all have in common is that we're giving them information. And so our students are the consumers of that kind of information. Boom, comes COVID reality, right? And so our labs, this is the same lab that I showed you before, just kind of a different angle in there, no students in there. And we went from having a lab to basically being a warehouse. We're putting all the materials inside of there. And at Skyline College, we took a really kind of concerted effort of that. We still wanted to have that hands-on lab material. Our students really need to kind of manipulate something. And so what we did is we made that transition is that we set up a bunch of boxes with a bunch of materials and we kind of sent them out to students. And so this is actually a picture of our lab just a couple of days ago. These boxes are coming, trouble is you don't think about it, but the boxes come back to you and you got to clean them up. You can tell them not to throw a bunch of the garbage out, but you still have it come back and it has the plates and everything all inside of there. And so I'm about 6'4" and these boxes are about a couple feet above my head. we manufacture some kits that we made. If you could also see, Bio-Rad has some excellent kits in there as well. Another COVID reality that we have is we actually tried to have some students come on campus. And so again, because we're doing biology, we were doing biotechnology, we can put on PPE, but we had little things of like, I don't know if you remember in the beginning last year of COVID that we had actually one-way hallways. And so to go to the bathroom, you had to like go down the floor and then come back and come up and go one way. And it was kind of really hard to do. And luckily we don't do that as much. Again, another COVID reality is just like seeing you here, we're having lectures on Zoom. But for me, a little bit more of the reality, it's great to kind of see everyone's faces in here. But I have classes where basically everyone has their camera off, everyone has their mic off, and I'm the only one in there. And I don't know about you, but for me, it's really hard to do that without seeing kind of people's faces. But the thing about COVID that we had, we've had this big disruption of our classes and our laboratory. But I've been trying, and Ying-Tsu and a number of my other colleagues have been trying to disrupt basically how we teach anyways, right? For us, for some of the things that we're looking at, the metrics, it's not working. And what COVID has really done is that we can, if we all come together, we can overnight basically change everything. And we did. And so what I really want to do is say, how can we get better after this past year? How can we take things that we've done and we've proved to work this past year and keep those, and then kind of throw some of the other stuff out? And so this didn't just come in this last year. We've been trying to do supply chain for a while. But again, being able to make those kits and send those kits out showed us that we can do supply chain. We can work with the supply chain. And so what I really wanted to do in our classes, if we see that before that first picture that I showed you of the students in the classroom getting information, the students in the laboratory, I don't know if you guys may do it a little bit different, but a lot of times when I'm doing a laboratory, especially for a majors class, I'll have a desk up in front with all the materials on it, and the students come up and they get the materials, they go back, they do the lab. We're doing it all kind of at the same time, lockstep. And they're learning their materials, they're learning kind of what they want to do, they're learning the biology, but is there a bunch of other stuff that they're not learning? And so what I want to do is get the students from being kind of in the demand pocket of the supply chain to actually being able to participate in the production and kind of looking at that. And so again, we want them to be a part of the transition about work and making the work and kind of understanding what an inventory is. Because again, supply chain is coming up a lot more in our lives. And Ying-Tsu was really good at showing you the supply chain with toilet paper and the supply chain with the vaccine. Does anyone know when the last 24 hours there's been another supply chain issue that's going up? What's going to get more expensive?
What is
People
it?
from Texas. What is this? Well, I mean, you could have said gasoline, right? Or you could have said beef, right? The prices of beef are supposed to go down. So there's a major producer of beef that was hacked, and there's something kind of going on with the supply chain on that. So we may see beef prices go up. And so what I wanted to do with this is tell you that a lot of the entry-level jobs that are out there are in the supply chain. And these are skills a lot of times and things that we think about. A lot of us think that we know a lot about supply chain. And I'm sure that all of us were talking about, toilet paper. And again, a year ago, trying to find ethyl alcohol or sanitizing wipes and stuff like that were in few demand. And so we need to look at that. And what I'm saying is what we want to do with supply chain is we want to build on the skills that students already have. And so supply chain, there's a lot of kind of interesting stuff out there. And so this is a game that they have in there. So this is a company called MBA Crystal. They're kind of an interesting company, but they set up this game and you have a demo on it. I'm just going to put up the demo for us to kind of look at. And there actually, if you do, there's called the beer supply chain that I can't use because I do some of this in the high schools, and I don't necessarily want to be talking about beer in the high schools. But I'm going to move this up a little bit. So in this game, I'm having a little bit of trouble seeing this. So in this game, the one thing that we need to do is to produce something. And what it is there's a 1 week lag where our product is in transit. So basically what we need to do is order materials. We get those materials in. We then basically get a week to work on the materials, and then that material goes into inventory. And so we have our customers. So basically, if you do inventory, you kind of look at kind of what have you done in the past. And what I'm going to say here, and so this inventory is stable, right? And so, biologists, you think about these things, but you think about like homeostasis, and your supply chain is going to be stable, because if you have your demand of 10 units and you're constantly producing 10 units, things are going to work okay. However, I'm just going to tell you right now that we're going to get 5 more customers. So starting next week, we're going to have 15 new customers instead of 10. And so we're thinking about our production. What do we need for our production? How many do we need to produce? What are people thinking? Should we do 10, 15, 30? I'm going to do 15, because we'll do, actually, I did 150. That's a little bit too much. I put it in there. So we got 150. But what we're having here is when you do this in demand, I did a little mistake in there, but that's looking at our inventory. And so one of the reasons why we don't want to have that much inventory is because we don't basically, it costs money to store stuff. And a lot of you, and if your labs are like mine, right now, we have our laboratories filled up with boxes. It's basically a warehouse. When we start teaching in person in the fall, we're going to be teaching about half our classes are going to be kind of half in the laboratory and half kind of at home. So we still need to do our kits at home. But what we're going to worry about is, where do we put all our boxes? Where do we put all the materials we're doing this? So inventory is a big thing. But what's happening here is that we have that list. So even though we went up by 5, our total demand went up because we have this back order, and we have these kind of unfilled orders that we need to look at. And so even though we have this idea of that we can handle this supply, when we look at our supply chain, it is actually going to, the supply chain is actually going to crash in a little bit. And what's really amazing is that a lot of us, for all these years, our supply chain has been working great. And you kind of don't think about it, right? You order something on Amazon, and in the Bay Area here, I can order some things on Amazon and I get them that afternoon, or I get them the next day. And when the pandemic started, I was starting to get things a week in advance. And for me, that was kind of really inconvenient, and I didn't want to do that. And so I'm going to go back. And what I just basically want to say is that, so at Skyline, we kind of focus in on teaching kind of high school students. So, I shouldn't say kind of. We'll teach what our biotech manufacturing program is working on is that we want to get students from the high schools, right, and we want to kind of put them through our program, and then we want to try and get them jobs. And the idea is that we have a diverse set of high schools that we are kind of picking from, and we're hoping to kind of increase the diversity by doing that. And then what we're seeing here is that our entry-level positions, and Jim actually did a market analysis for his Nimble grant. And one of the things that they pull out, and you always see that we have a big demand for, are these things that called inspectors, testers, sorters, samplers, and weighers. And these things don't necessarily, they need some training on that, but they don't necessarily need a lot of training. And what our idea is that we would get these students in that normally wouldn't think of themselves, maybe even as college students, definitely wouldn't think of themselves as doing something as kind of difficult as biology, right? Or biotechnology. I don't understand the biotechnology. And then we want to get them into positions and get them doing some pretty heavy biochemistry. Again, if we can make antibodies, if we can make green fluorescent protein, that's kind of interesting stuff that they can do, right? And so what we want to try and do is kind of build on the skills that they have. We want to build on to give them more biotech skills, but also kind of build on their soft skills. And then basically what I wanted to say here is that, a lot of these beginning jobs is in sorters, testers, sorters, samplers, and weighers. They're actually kind of looking at students to build up on their soft skills. We're looking at communication. We're looking at critical thinking. We're looking at kind of honesty. Well, we've had a number of talks with our industry advisory group. We've had a number of talks in California. If a number of people have been doing that, we've been looking at this. We ask, you ask your employees, what do you want? And they don't necessarily say pipetting skills. They don't say those other skills. Basically, they say that we want these people with some soft skills. And so our idea is, can we get some of these high school students to come in with and kind of increase their soft skills, but also increase their biology skills, their biotechnology skills. And how I really kind of envision doing this, or how we envision doing this, is basically through a supply chain lens at Skyline College. And so Skyline College, we want to act as a contract manufacturing organization, and we are working with basically a distributor. And so BayBack, that Ying-Tsu works for, they're a distributor, and they have the perfect biotech product, if you really kind of think about it. And so we've been talking a lot about the regulation and kind of everything else that you have on there. And so what we want to do is use BayBack to distribute. And if you look at, this is a business model that basically a lot of pharmaceuticals have. You don't buy your drugs directly from Moderna. For the most part, there's a kind of a marketplace in the middle, kind of a middleman that sells that. And so what I would like to do is to take something biological, something biotechnological, right? And again, it could be an enzyme, it could be an antibody, but let's make it a little bit simpler. Let's make it be plates. Let's make it be solutions. Let's make it be tests. And what happens is Skyline acts as a contract manufacturing organization, and that we supply this on an open market. And that market is kept and maintained by BayBack. It's a lot of work in order to do this market. And so BayBack has this community that they respond to. And what they do is they set up the market. Now, this picture here is a little bit old. And so BayBack now actually stands for Bay Area Bio Life Sciences Education Community. And again, we wanted to bio life sciences rather than biotechnology. And what we're doing here is the community colleges would act to make the tests, the supplies, the reagents. We would do some calibration. We could possibly do some testing. And the ultimate customer, the consumer of this, would be those high school students. And so number one, they get their packaging from us. It has kind of our name all over it. There's a lot of kind of synergy that we have on there. While we don't have to do this to pharmaceutical quality, I want to do it to pharmaceutical quality. And so when people talk about, to me, it's like, oh, you only made that number of plates. I could have my high school student go and make those plates a lot quicker. But what I'm doing is I'm using this, I'm trying to do this pharmaceutical grade, and I'm trying to do this using the quality control and everything else. And so what we can do is we can have these products be made to pharmaceutical specs, but we're using them in the classroom. And that way, if there's a mistake, then there's not that big of a consequences from that when they do it, rather than going into and doing a pharmaceutical company. Again, why I say these are great products is that if I had my students make insulin, which we could do, no one would use it. Green fluorescent protein, we've made that, but you can only make so much of it. Again, I would like to actually have a big pile of green fluorescent protein. That would actually be fun to actually do that, to maybe make like 100 grams or something like that. But besides that, there's really nothing kind of else that you can do with green fluorescent protein. And so what I want to do is kind of be able to get that aha moment and that pride of manufacturing by actually making something that's actually used. And so, again, Ying-Tsu showed you this. And so we have a marketplace. This marketplace is very easy to set up. It's basically a Google Sheet that you can control who edits that sheet. And so I just need to go to that sheet kind of once a week and say, hey, what are the materials that we have inside of there? What can I look at? And then I post on the bottom here is on that Google Sheet, we have, you can look at it once. So I can look at, do I want to make media? Do I want to make kind of BayBack has a kit that has a lysis solution where you break open cells to release the DNA, and we can make that material in there as well. Again, I want my program to work, and I have some pictures in here of students. Sorry, I got to put it near my beautiful students, so I always want to kind of show them off. And basically what we are, sorry. Do my presentation again. Sorry. Let's breathe a little bit. So our final customer, while it's BayBack, what I want to do is I don't want to put all my eggs in one basket. And what I've seen when we're supplying the stuff to BayBack is say like, hey, we can, if we have excess capacity, we can provide our microbiology class and our other biotechnology classes with materials. And so in the beginning, when I tried this, over a year ago, Our lab tech says, no, I don't want to do it. I don't trust your students making materials and things like that. And then when we start these at-home kits, our lab tech was swamped, and he's like, yeah, I'll take all the help that you have. And a lot of it is, again, he had the materials. He didn't have as much work. He worked with us to develop an SOP or a manufacturing formula, and we filled that out, a batch record, and he was really kind of happy with it. So again, now we're kind of ensconced inside of there. As well as the internal customers, I would like to kind of make some outside customers as well. And so what we're looking at is these outside customers. I don't know if you have it around you, but around us, we have these science fairs. And so actually I have my students actually go in and they develop a project to do. They source the materials, they order the materials, they have a budget on the materials that they need to do. And so these pictures are here of, we actually have the Bay Area Science Symposium, the Giants, actually open up the stadium at the beginning of September, end of October. They open it up and they have a big science fair, and it's meant for kids. And so our students will set up a project. They have to basically service maybe about 200 or 300 kids walking by an hour. So they may be doing during a day, they may do an hour. And so they have to schedule who needs to be there, kind of what are the materials. Again, we're looking at budget. So we look at kind of all of this, and it's a kind of a fun thing to do. We are looking for more customers. So if any of you have little things that you want to make, and I love us kind of talking about antibodies and about making antibodies and split. I love us talking about something like Taq polymerase. The other day, we talked about it. We have a small biotech company that's really close to us, a little bit west of our campus called Genentech. And a while ago, they had a big bucket of 20 liters of protein A medium that. I said, I can't use it. I can't use that much, and I don't want to have to dispose of it. That wouldn't it be great if we could kind of repackage somehow and send that out? And again, you look at some of your analytical labs that have smaller, they've asked for, hey, can you use some glucose? And I'm like, yeah, sure, I can use some glucose. And it's not like a 500 gram bottle of glucose. They're talking about a pallet that has 10, 20 kilo bags on top of it. And so, again, our students, if we are able to somehow kind of take that material, kind of repackage it, our students would get an idea of what it is to deal with large amounts of materials. And, the jobs that I said, one of the things on the jobs is must be able to lift up 50 pounds. You don't think about that when you think about a biotech job, but on some of these jobs, they're actually doing physical manual labor. They're taking sacks and putting it from one area to another. And so what I just like to say is that this kind of market exists, and we can develop this market a little bit. And what you need to do, what you can do in your situation is to get a product, get a customer, and just start kind of making your product. So I'm trying to keep with the time in here. So what I want to do is going to the classes. Can I do this in the classes? And so this is looking at the courses that we have for our biomanufacturing assistant certificate. And so in the first year, they have what's called a Biotech 400 class, which is Foundations in Biotechnology. And so they're learning about what biotechnology companies are, what the various types of biotechnology, right? You have white biotechnology, green biotechnology, and red biotechnology, right? Pharmaceuticals. And then in this class, they'll learn about sterile technique, and you may have them make some media and things like that. What I really like about these classes, I can have my upper division classes actually work with the lower division classes. I'm calling these first year classes, second year classes are working and doing quality control for those classes. But what we're finding that is the supply chain in the classes was okay, but it seemed like we were kind of always behind. And so that exercise that we saw in the beginning, where that some materials are coming through, and so you have a perturbation in it, and you still can't keep up. And we kind of had the same thing in the classroom, is that we weren't able to keep up with the kind of demand that we have. And so actually Doug Bruce and Leslie, who I know is here on the talk, Leslie Blackie, who's here on the talk, they actually have a club that they use to do their manufacturing in their club. And so what I did is this is the Instagram account for Skyline Biomanufacturing. here's Laney Clubs. They have a lot more followers and stuff, and they hire a publicist to do a little bit of their stuff. And so they've been around a little bit longer. But what I wanted to do then is, kind of compare. And so if you're going to do kind of this a Bioscope project, do you do it in a class? Do you do it in a club? And what I want to say is that, so one of the things that we have is basically we can look at things like training. In the club, the training is going to be hard because basically the club, the students are going to want to be there for fun, right? And you're not going to be able to have them sit down and do the training as much, although you can do it if you do it right. In the class, it's part of a class. The students are supposed to be there, and you can do extensive training on this. And you can have one day where they read the SOPs. You have another day where you're testing on the SOPs. You can have another day where you're going to have them kind of make their SOPs. Again, for a club, attendance can be sporadic. If you have a final exam, you're not going to see a lot of people in that club that week. Or if you have midterms, you may not see that. In the class, it's required. They're going to be there. The big thing that we have with clubs is kind of matching the student learning outcomes. And in the class, you have to actually match those student learning outcomes. So I can't do a lot of manufacturing in a class because, again, you make plates one time, right? That's great. But, and they know the concept and they know the sterile technique and they know how to mix the materials and stuff in there. But then you need to go on, you need to do something else because there is a course outline of record, that document that you have to match. You can't have those students. Whereas in the club, I'm not really kind of following the SLOs. And what we can do in the club is we can have students develop mastery of the topic. And so again, they're working in the class, but in the club, they're doing it. They may do it first in the class, but in the club, they do it kind of many times. The club is also, we're able to pivot. And so if you have a kind of a rush order or some other type of order that comes in, you're able to kind of do that. In the class, that's very hard to do, right? Because in the class, you have curriculum that you have to do. I set up my syllabus in the beginning of class, and you really kind of can't change that syllabus during the semester. So you can't kind of rise to those occasions. And so, I have a neat kind of story about this is one time Laney actually, they found the marketplace and there was a set of plates that needed to be made for kind of the next week. And Laney was making those plates. And I was like, oh, I wanted to make those plates, but Laney got to it first. And what happens is when they were setting it up on their club, Laney had a fire on campus. And so all the students had to leave campus and they had to leave basically their plates and their media out there. And they basically lost it. And then what was happening, Ying-Tsu kind of went to me. He's like, oh, we lost this. Are you able to do that? And the next day I was having my club meet and we were able to pour all those plates for it. And so again, you can pivot, you can do stuff like that. And so if you have a marketplace, sorry. The next thing is, again, Ying-Tsu was always talking to me about, can we make this sustainable? And what I just like to say is in the class, it's hard. I can't really kind of charge for things that are made inside the class. I do have a budget for the class that we have for labs that I can use to kind of purchase materials and things like that. But I don't have any way of kind of keeping that going. Whereas I would say that our clubs are actually, a lot of times, that's one of the things that they do is they do fundraising. And so we do have a way of getting that. And I don't know if any of you guys have tried since 9/11 trying to open up a bank account for a club or Boy Scouts or something else like that. You have to have a federal ID number. And at least for me, it's been kind of really hard to do it. And so we actually have no way of kind of accepting money. If somebody writes you out a check for your club, I don't have a bank account for the club for the club. Yet from the club for the college through the student association, there is some banking that you can do there. I wanted to kind of give you some of the pictures inside of here of our students. Again, because it's a club, it has to be a little bit fun. So not only do we do our manufacturing, but we'll go out for hikes. This is on our campus. We're in a beautiful campus that overlooks the Pacific Ocean. I wanted to kind of go a little bit faster now. Sorry about that. What I want to say is that running a club, finding and keeping customers is very hard. And I like to be a teacher, to keep up to date on information. I don't necessarily like to do all this stuff. I don't necessarily want to call up people and say, hey, do you want some materials? I do that every once in a while, but that's not necessarily fun for me. And what I needed is somebody else to kind of do it for me. And so the idea was that we have a student supply chain project manager. And so the students, rather than just being kind of worker bees, can pull out some of the students who are kind of good at what they do and kind of upskill them a little bit. And so those students are scheduling the club meetings. Those students, that's their friends out there. And one of the reasons why they come to the club meeting is that that students is asking them to come to the club meetings. We also kind of make it fun. We kind of incorporate some games into it and some other things in it as well. They have many interactions back and forth with the customers. You tend to not think about it, but Ying-Tsu can all the time is that we were making some Kelex solution and you'd say, oh, I just want a Kelex solution. You can buy it, but there are different forms of Kelex that Biorad makes one form. There's another forms. There's different sizes of Kelex. And so what you need to do is kind of go back and forth is this material acceptable to you? And so there's a lot of that kind of goes on in the background that you don't see. And again, if we have a student do that, they're learning how to do that. They're learning how to plan and everything else. The second thing is that, I don't know if you've ever done manufacturing or things like that before, but, it always takes longer than you think it does. And you may end up with kind of packaging and delivering. And you tend to not think about it. But again, your product to go from your laboratories to the UPS office or your package to go out somewhere else, that takes time to do this. And having a student being able to do that is kind of really helpful. So take a little break, some of the products that we have. So here are our students actually manufacturing. We use some Jelly Bellies and Jelly Bellies to look at quality. And so we so as one of our package that we send out for students is we package up these Jelly Bellies and the students kind of look at them, they can eat them. Here's some plates. That's probably about 900 plates. We use a plate pourer. So we do have a piece of equipment that will be able to do that. But, it took us so you talk about installation, when you took installation qualification, it took us 6 months to install this piece of equipment and finally get it to go. But that's kind of another story. With COVID, we're doing some packaging and our students need to have masks and they need to be separated. And so here are some of the packaging. But again, we're not just making one of something for laboratory, we're making, 120 of something. And so how do you make that many of something and have it be the same kind of all the time? We again, the student position is very critical for that. Again, what we're doing with student position is you're kind of leveraging this a little bit. And so when we have our student position, we actually put out the job announcement for the student position when the students are kind of writing up their resumes and learning how to apply for jobs. And so this is a real job that students can apply for. But I know some of you, and I talk to some of you and you say, oh, I get students, I just get the best student in class and I ask them to come and work for me. And what I'm saying is that, what we really should do is I get this position, I send it out on the whole campus. And I look for the best person in our micro classes, in our general biology classes, and it does a couple of things is I'm able to possibly get another student out of it, but I'm also getting the idea of the biotech and the biotech program into these other areas. And so I have BayBack has been actually really good at sending people to help interview these people. I also have some of my past student project managers, definitely in that first round of interviews. I'm not in the room because I'm there kind of supporting the students and making sure that they have their resumes and kind of everything else. And so I'm not in there. And so basically what I do is they pick a number of people and we kind of do a final interview and I'm in on that. The idea that we also have is we want to make this sustainable so that when we onboard our students, they have an understanding that they're going to train the next students and what that's really, really critical. So I really, in theory, I would like to keep a student kind of working at maximal capacity for roughly about a semester. Right. And then they're training that kind of next student. So we need to have a little bit of overlap on the students. Some hints for a good supply chain manager. You get a supply chain manager, and so you network with students in class. This person should be attending the club meetings. So a lot of times we have hired with students not attending the club meetings, but for the most part they do. Again, we plan for our club. We plan our manufacturing dates at the beginning of the semester, so students can plan on the semester. We typically have a date. We do ours like either a Friday morning or Friday afternoons. With our students, we actually, what we do is we meet on Tuesdays. So we're going to have a manufacturing day on Friday. So we meet on a Tuesday and the student will develop the agenda and the process, or we call them shift changes for the students that they're going to do. We will try and get everything done in writing. right? So you can't have, so we have a number of different layers of talks. The students is actually going to be maybe talking to Ying-Tsu, or actually not even Ying-Tsu, they're going to be talking to somebody else who manages the projects for BayBack as well. And so what's really critical is that this gets done in writing, and that other people kind of know what's doing it. A big thing that we have is our students tend to not fill out batch records. And so if you look at kind of where the FDA dings people on, is that they don't fill out their records right. And so, as much as I can, it's very hard to get my students to do it. I don't want to be harping on them all the time. So it's really nice to have a student there, somebody else kind of reminding the students to fill out their batch works. And then we keep a running tally of what's done. And so this is Ryan Flynn, who's our newest iteration of this enroll. So he's working hard on that. And then the next thing that we want to do is kind of look at sustainability. What we're doing is right now, this position is being supported on grants, but we want to eventually kind of incorporate this. So maybe this is the lab technician that is hired by our division. But in order to do that, I need to look at kind of what are the cost savings. And so these are the material goods that were supplied this semester to our classes. And, I put that in front of my dean all the time so that she knows what's going on. So basically what I want to do in summary here for my part is just to say that at Skyline, we use a partnership with a local nonprofit to actually make a biotech product in our classrooms. We found that we didn't have it enough mobility in our classrooms, so we actually developed the club. We at Skyline College want to act as a contract manufacturing organization. So if all of you out there know of something that we can manufacture for you or somebody else, kind of let us know about that. We feel that actually using this, incorporating the supply chain into our classroom will make it more interesting for our students, and that will actually pay off for them being more able to get jobs in kind of the local industry. And so here's just more pictures of our students. And Ying-Tsu, you were going to go over the wrap up, or?
I don't have to. Purnima, are we low on time?
A little bit, but if you can take just a minute, that would be fine.
Okay.
Thank you.
Next
This
slide.
is so amazing. A nice wrap up would be really appreciated, I'm sure.
And Nick, next slide. Okay, so I just want to talk a little bit about the supply chain guidelines project that's going on in the state of California. We are working with the statewide director for life science and biotech, Tara Quenzer, in creating this guidelines report for the implementation of supply chain. So what we are doing is having industry and faculty practitioners to help with specific projects for supply chain. And what I mean by that is specific projects for pouring plates, or making buffers, or making plasmids, or doing an analysis with PCR, for example. And so what we are doing is providing a roadmap for faculty to implement supply chain in their courses. What are the skills that students need to make certain products, for example? We are working on supplying templates or syllabi, timelines, batch records for faculty to adapt, because I think that if we provide something that's useful, that you can easily take and almost turnkey, then it will be useful and helpful for you. We are exploring micro-credentialing with Angela and Heather, badging for students. And we are training statewide faculty in supply chain implementation, as well as injecting a lot of quality checks into this whole process. And what we, in a far future, is to adapt it within life science and across sectors. Next slide. And this is just an example of what we have come up with so far for technical skills. This is one of the 6 skills sets that we have had the task force, our faculty practitioners, help with creating. So we still have to clean up some of this, and we are hoping that it can go on to InnovATEBIO's website. I don't know, maybe I'm saying things too quickly here, but maybe by fall. So if you have any questions, just email us. Thank you very much.
Thank you so much. That was a lot of content that was done very quickly. I really appreciate that. Thank you.